Okay, I want you to picture something. Imagine a world of just bare, black rock, right? Freshly cool lava stretching out as far as you can see. There's no soil, no water, no life. It really looks like the end of the world, but it's not.
It's actually the very beginning, because even in a place like this, a single, tiny, brave little organism is about to show up and change absolutely everything. This is the story of how nature builds entire worlds from nothing. Now, this whole process, it has a name. It's called ecological succession. The best way to think about it is like chapters in a book. Nature has a story it tells everywhere on Earth, and it almost always follows a predictable pattern. Each stage sets the scene perfectly for what comes next.
So the first version of this story is by far the most dramatic. We call it primary succession, and it's literally the process of creating life from scratch. So where does something like this even happen? Well, we see it on brand new volcanic islands, or on the raw rock that's left behind when a giant glacier melts and retreats. You see it on newly formed sand dunes, or even in a brand new lifeless pond. The one thing they all have in common: they are a total blank slate, no life, and, this is the important part, absolutely no soil. So who in the world would be brave enough to move into a place with no soil, no water, and no food? Meet the pioneer species, and among them are lichens, they're just amazing. See, a lichen isn't just one plant. It's a team of fungus and an algae working together. And they perform this kind of magic. They release acids that literally break down solid rock, creating the very first tiny particles of soil. I mean, think about that. Life itself creates the conditions for more life to exist. So the journey starts on bare rock. Then our pioneers, the lichens and mosses, they arrive. Over many, many years, they create a thin little layer of soil. And that soil, well, it allows small plants and grasses to finally get a foothold. As they grow and die, they add more organic matter. They enrich the soil, making it possible for shrubs and eventually huge trees to grow. This entire process, from solid rock to a full-blown forest, can take hundreds and hundreds of years. And the final destination of this really long journey is what we call the climax community. This is the stable, mature ecosystem that, it doesn't change a whole lot over time. So what decides if that climax community is going to be a rainforest, a desert, or a grassland? It really comes down to just two things: temperature and rainfall. The climate is the ultimate architect here. All right, so that's how you build an entire ecosystem from zero. But what happens when an existing community gets damaged but not completely wiped out? Well, that leads us to a totally different kind of recovery. This is where secondary succession comes in. Think about a forest fire, a flood, or even just an old farm field that's been abandoned. These are major disturbances, right? They cause massive damage, but they don't erase everything. Life is still there, just waiting for a chance to rebuild. And right here is the crucial difference. Primary succession, remember, starts with bare rock. It has to create soil from scratch, which is incredibly slow. We're talking centuries. But secondary succession starts after a disturbance, and the soil is already in place. Seeds, nutrients, maybe even some root systems, they all could have survived underground. And because it's not starting from zero, the recovery is much, much faster. Now we're talking decades, not centuries. So how did these first species even get there and manage to survive? Well, they've got a whole arsenal of secret weapons. Their seeds are tiny and light, basically designed to be carried by the wind. They grow incredibly fast to stake their claim. They can handle extreme heat and drought, and some of them can literally create their own soil or pull essential nutrients like nitrogen right out of the thin air. They really are nature's ultimate survivors. Okay, now that we get the process of change, let's take a look at the end result. Those stable climax communities we talked about? Well, they have names. So let's go on a quick world tour to explore Earth's 8 major land environments, also known as biomes. But before we go, you need to remember one simple, super powerful rule that governs everything we're about to see. Ready? Temperature plus precipitation or rainfall equals the biome type. That's it. That is the formula for life's address on planet Earth. Our tour is going to start in the extreme cold. First up, the tundra. The defining feature here is permafrost, basically a layer of permanently frozen soil. And that frozen ground prevents large trees from taking root, which is why you get this landscape of low-lying shrubs and mosses. Now, just south of the tundra, we enter the taiga. This is the Great Northern Coniferous Forest, a huge belt of spruce, fir, and pine trees. It's actually the largest land biome on Earth, and it acts like a massive carbon sink, playing a huge role in regulating our planet's climate. Now for a total change of scenery, from the cold to the extremes of heat and water. The tropical rainforest, which you find near the equator, is warm and wet all year long. This stable, nurturing climate is what fuels the highest biodiversity on the entire planet. Over half of the world's species live here. And at the complete other extreme, you have the desert. It's defined by its lack of water and these huge temperature swings, from scorching hot days to literally freezing nights. Life here is all about extreme adaptations and saving every single last drop of moisture. Next up, let's head to the world's great open spaces. The savanna is a grassland dotted with trees, famous for its dramatic rainy and dry seasons. And what's really interesting is that this biome is actively maintained by things like seasonal fires and large grazing animals, which actually prevent it from becoming a dense forest. Then you have the temperate grassland, like the American prairie. It has more extreme seasons with hot summers and cold winters. Its soil is incredibly rich, which is why these grasslands have become some of the most important farming regions on the planet. And finally, we visit a couple of biomes that are defined by their distinct seasons. The Mediterranean biome has a really unique climate with hot, dry summers and mild, wet winters, which supports all these hardy, drought-resistant shrubs. And then we have the temperate deciduous forest, which many of us would recognize from its 4 classic seasons. The defining feature here? Trees like oaks and maples that have that brilliant color change and then drop their leaves each winter, which is really just a clever strategy to save water and energy until spring comes back. So we've basically traveled the whole world. But what if I told you that you could take that exact same trip from the equator all the way to the poles just by climbing a single, really tall mountain? Yeah, here's how it works. It's a fundamental rule of nature. As you go up in altitude, the temperature drops. To be specific, it gets about 6.5 degrees Celsius colder for every 1,000 meters you climb. And you can see this perfectly on a mountain like Kilimanjaro in Africa, because it's right near the equator, its base is a lush tropical rainforest. But as you climb, the temperature drops and you enter a temperate forest. Climb even higher, it gets colder still, and it transitions into an alpine tundra, which looks a lot like the Arctic. And then, at the very top, you find permanent ice and snow. You've just traveled from the equator to the pole, just by going up. Okay, one last, really crucial idea. We call those climax communities stable, but that doesn't mean they're permanent. If the underlying climate changes over a long period of time, let's say an area gets a lot drier over a few centuries, a forest climax community could slowly be replaced by a grassland. The community always adapts to the climate. Whew. So, we've journeyed all the way from bare rock to the top of a mountain, and we've covered the fundamental rules for how life organizes itself on this planet. Let's just quickly recap the key takeaways. Here is what you really need to remember. First, succession is nature's predictable story of change. Primary succession builds from scratch, while secondary succession rebuilds what was there before. The type of biome you find in a place, that's all determined by temperature and rainfall. Climbing a mountain is just like traveling from the equator to the poles. And finally, ecosystems aren't static, they're dynamic systems that are constantly responding to their environment. And that leaves us with one final thought. If nature truly has the power to turn bare, lifeless rock into a thriving forest over time, what does that teach us about its resilience and its incredible power to rebuild? And maybe more importantly, what does it say about our role in protecting the very foundations, like soil and water, that make all of that recovery possible in the first place?